a 3.00 kilogram car A over here, traveling at 8.5 meters per second on a frictionless track, collides and sticks onto a stationary 2 kilogram car B over here. Okay, they stick together and then they travel up this ramp, and the question is asking, what height will the two cars reach? Okay, so before we start this problem, we need to think about what's happening here. First, car A collides with car B and they stick together. So what kind of collision is this? This would be an inelastic collision because they're stuck together. Now that they're moving together, they're going to gain height as they go up the ramp, and as they're gaining their height, they're losing their speed. Okay, so you're going to have a transfer of energy. It's frictionless, and there's no other external forces acting on the system, so we can just say the total energy initially equals the total energy final. Okay, so we're going to divide this into two parts. The first part, part A, we'll say is the collision. And this, we said, was an inelastic collision because A and B stick together. So for every collision, it's momentum that's conserved. So momentum total, so the letter for momentum is P. P total initial before the collision equals P total after the collision. Okay, so the formula for momentum is mass times velocity. So we have the mass of A times the velocity of A initially, plus the mass of car B times the velocity of car B initially, is equal to, now they're stuck together. So the mass of the full object that's stuck together would be the mass of A plus the mass of B times their final velocity. Okay, so they're stuck together, we're treating them as just one object. So first we're going to solve for this final velocity. So I'm just rearranging the formula. And now I'm going to plug everything in. So I have the mass of A, which is 3 kilograms, the velocity of A, which is 8.5 meters per second, plus the mass of B, which is 2 kilograms, the velocity of B, which initially it's stationary, so it was 0, over the mass of A plus the mass of B, so 3 plus 2. Okay, so I'm just going to type all of this into my calculator. And I get 5.1. Exactly 5.1, so I didn't round here. So 5.1 meters per second. Okay, so that was the first part, the collision. The next thing that happens is that now that A and B are stuck together, okay, I'm going to treat them as though they're just one big object. Oops, not C, it's A. I'm going to treat them as though they're just one big object with a mass of 5 kilograms. So AB together, 3 kilograms and 2 kilograms, so together we have this 5 kilogram mass that is now going to be just traveling up this track. Okay, in this picture there are wheels here, which makes you think that it's rolling up the track, but there is no mention at all anything about those wheels. We don't know what the size of those wheels are or anything, like what the radius is, so we're just going to simplify this and pretend like they are just blocks and they are just sliding up the track. Okay, so part B then is this mass, this 5 kilogram mass that is sliding up the ramp. So we're going to call that energy transfer. So we'll say that the total energy initial is equal to the total energy final. So by initial, now I'm saying right here when they're stuck together, that's initial, and final is when they've reached their maximum height. That's the final position. Okay, so the initial for part A, so the initial for the part A, the collision, was over here, and the final was over here. Now for the second part, the initial is at this point over here, after the two objects have collided, and the final is when they're at their maximum height. Okay, so E total initial equals E total final. So I'm going to put in all the types of energy that we know about. We have kinetic energy, and we have gravitational potential energy. Okay, we do have translational and rotational kinetic energy, but as I said in this question, we're treating these as though they're just blocks and they're sliding. Nothing is rotating. We don't know anything about those wheels and their radii, so we can't even do anything with any type of rotation in this question. We have gravitational potential energy, and the other type of energy that we know of is the elastic potential energy, but there is no spring in the question, so we're going to ignore that. Okay, so we're looking at kinetic and gravitational potential, both initial and final. So the total energy initial equals the total energy final. Now let's think about what is zero in the question. So we first need to define where our reference position is. We're going to say at the bottom of this ramp, that's where our height is 0. So then initially the height is 0, which means that there's no gravitational potential energy. And when the object reaches its maximum height, that means it comes to a stop at that moment in time. If it comes to a stop, it has no velocity, so therefore it has no kinetic energy. So our equation now, it just tells us that our initial kinetic energy becomes transferred into our final gravitational potential energy. So our speed that we had at the beginning becomes a height at the end. Okay, so I'll put in our equations for our kinetic energy, 1/2 mv squared, and gravitational potential energy, mgh. Okay, since we're assuming to be close to the surface of the Earth, we can use this formula. We don't need to use the long formula for UG that we learned later on in the course. Okay, so the mass is the same on both sides of the equation. We could just cancel it out or divide both sides by mass. We're trying to find the HF, so I'm going to rearrange and solve for HF. So I have 1/2 V initial squared over G. And now I can plug in everything I know. 1/2. So my V initial is the V, the velocity after the collision, which is what we found in part A. So that's 5.1 squared. And my G, since I'm close to the surface of the Earth, is just 9.8. So I'm going to type this into my calculator. And I get 1.33 meters. Now if I go to the original question, I'll just check for significant figures. I have 3 significant figures, 3 significant figures, and 3 significant figures, so my answer should also have 3. So I am all good with 1.33 meters. Thanks for watching.